So here we are, John. You're going to give your talk on Michael Combrune and the chemistry of brewing in a moment.
Yeah,
But could you perhaps, while I'm still letting people in, tell us a bit about yourself and how you became interested in the topic?
sure. So, my name's John Powers. As you can see from the slide, I'm a professor of history at Virginia Commonwealth University in Richmond, Virginia. It's a rainy 9 a.m. here in Richmond. Um, I became interested in it. I'm a historian of science and chemistry. I worked on the introduction of thermometers into chemistry for a while. I'm kind of moving on to a new project on Joseph Priestley at the moment. So this is a little bit of an older project that I've been working on, which one day I will finish and publish. But the connection here is that my first book was on Herman Boerhaave, and Herman Boerhaave turns out is the source of ideas for Michael Combrune and his program for brewing. So I'll talk about that today in the talk. The other thing I should admit to is that I do home brewing of beer as well. So that was another interest that kind of went into my interest in studying the history of brewing. So.
Okay, well, thank you very much for that intro, John. We now have 39 people present and they're still coming in. So I will introduce formally this time John Powers from Virginia Commonwealth University, who's going to talk to us about Michael Combrune and the chemistry of brewing in the 18th century. And just before I allow him to start, I'll just say that in some respects, and it wasn't John's intention, I might add, this is a kind of commemoration of Ray Anderson, who was a long-time committee member of the group and a great expert on the history of brewing, having worked for Burton Brewery for many, many years, and so we greatly missed him. So on that sad note, John, can you start?
Thanks. Uh, so first, I'd like to thank Robert for inviting me for now the third time. I've always found giving these talks enjoyable, and so I hope this one will be enjoyable for everyone as well. So let me get my slides going. Okay. So, one trend in the history of 18th century chemistry of late has been looking at the different kinds of chemists who practice. And to start with, I'm going to start off with a little bit of what's really kind of an artificial division between artisanal chemists and what I call philosophical chemists. So philosophical chemists are chemists who study chemistry and who are professors teaching at universities, usually medical professors, or educated gentlemen, the kind of person who would be a member of a scientific society. And they tend to learn about chemistry, or their interest in chemistry is guided by philosophy, or they interpret changes in matter through theoretical entities like particles or atoms or chemical principles, laws of nature, that kind of thing. And they tend to learn about chemistry through reading books, and they write books about chemistry. On the other side of the divide, you have artisans, artisanal chemistry, and these are individuals who are chemists by way of the fact that they earn their living through one of the chemical trades. So these are apothecaries, um, you know, glass blowers, assayers, dyers, and so forth. And they tend to be trained through apprenticeship, that is, apprenticing themselves to a master chemist, a master apothecary, a master dyer, and so forth, and learning how to practice a chemical trade that way. Now, the way that these kind of chemists understand chemistry, um, uses an idea that I'm borrowing from another historian, Pamela Smith. Um, and that idea is the idea of artisanal epistemology. That is, that the chemical artisan uh, possesses an empirical and experiential understanding of the materials that they work with. That is, they've trained their senses to be able to read the empirical signs in that occur during their chemical processes, and then they can use their experience to make a judgment to determine whether or not their particular process is going according to plan or not, and if not, what needs to be done to get it back on track. Now, of course, this little division that I've constructed here is completely false. I mean, because every apothecary by the 18th century, more or less, read chemical books, attended chemical lectures, used theoretical concepts like chemical principles and so forth. And on the other hand, the so-called philosophical chemists, even university people who become university medical professors who teach chemistry, uh, 9 times out of 10 learn how to do chemistry in a laboratory of an apothecary or some other practicing, usually artisanal chemist. So this division that I'm creating is a little bit of a false dichotomy, but I want to sort of lay these two things out for you because this tension between the different approaches to chemistry in the 18th century, especially within brewing, is what I'm going to be talking about in my talk today. Um, in fact, when you look at 18th century chemistry as a whole, what you find is that there are a lot of collaborations between chemists of different stripes. For example, historian Ursula Klein has uh, published several papers about collaborations between elite chemists, who are members of scientific societies, and artisan chemists, and even some unskilled workers who come together to solve problems in, for example, the making of German porcelain or in German glassworks and things like that. So, um, one interesting outgrowth of these kind of collaborations, at least in the 18th century, was the development of projects to, as they were always called, improve the arts. And in Britain, this was not an old idea at all. And in fact, it was a key element of the philosophy of Sir Francis Bacon, whose ideas shaped the early mission of the Royal Society of London. And by the mid 18th century, this manifested itself in projects to improve various kinds of arts and trades that were promoted by such luminaries as Peter Shaw, who I've put there on the screen for you, but also other names that you might know, William Cullen and Joseph Black. Um, so uh, while most of the people who study this, the historians who study this kind of thing, tend to look at it from the perspective of the elite chemists like Shaw or Black or Cullen, and look at their sort of programs for reforming the arts. I'm going to, in this talk, kind of flip the script a little bit and look at a program to reform a chemical art, brewing, that was put forward by a practicing brewer, by a chemical artisan. So today I'll be focusing on the work of Michael Combrune, who is a practicing brewer from a Huguenot family that had emigrated to Britain and who set up a brewery just outside of London. Combrune argued that brewing as a chemical art must, at least on some level, follow the rules and principles of chemistry. And he proposed to reform the art of brewing by incorporating chemical knowledge from one of the most prominent chemists of the early 18th century, the Dutch medical professor Herman Boerhaave, who's pictured there on the screen. Now, one of the aspects of Boerhaave's chemistry, his innovation in chemistry and chemical teaching was to incorporate thermometry into his chemistry. That is, Boerhaave argued that understanding the heat generated and sometimes heat required in order for certain chemical reactions and processes to take place was an important area to study. And so what Combrune does is Combrune kind of adopted several aspects of Boerhaave's chemistry, but what I'm going to focus on is specifically Combrune's adoption of Boerhaave's thermometry. And with that, he devised a plan to use thermometers and specifically Fahrenheit thermometers, because those were the thermometers that Boerhaave used in his own classes and his research at the University of Leiden. So Combrune recommended or proposed using the Fahrenheit thermometer as the instrument that brewers then should use to control various processes in their craft. Now, just to cut to the chase here, most of Combrune's plans for reform failed. However, I will also point out that many aspects of his plan, specifically some of the aspects related to thermometry, were actually successful. And what I'm going to spend most of the talk on is trying to explain why that is. And my answer is that many of the brewing practices of the day, of the mid 18th century, were grounded in the sensory perceptions and judgments of the brewer. That is, brewers were artisanal chemists who practice a version of this artisanal epistemology, which I mentioned a few moments ago. And this could apply from things such as a brewer's ability to judge the quality of the starting materials like malt, water, interpret the empirical signs, whether the fermentation was going well, and so forth. Let's see. Now, the tension here that I'm going to be talking about is the fact that Herman Boerhaave's use of thermometers was not committed to any kind of an empirical program in the same way that the brewers were. In fact, when Boerhaave presented thermometers to his students at the University of Leiden, and then in his textbook, Elementa Chemiae, translated into English, which is just Elements of Chemistry, Boerhaave constructed, at least rhetorically, thermometers as useful because they were superior to the human senses, right? They corrected mistakes in perception and also revealed phenomena that the human senses simply could not, right? So Combrune, for his part, saw in the Fahrenheit thermometer as a means to correct, improve, and to some extent standardize brewing processes. So you didn't have to rely on individual brewers and their judgments anymore. You could just rely on the proper use of an instrument. So by discovering the optimum degrees of heat for each process in the entire brewing process, all products, according to Combrune, could be the best that they could possibly be, and the consistency of the brewed product could be maintained. So again, the problem here for many of Combrune's methods was that the new sort of use of thermometers in some ways undermine the traditional brewing practices. In a word, the thermometer could be seen as a disruptive instrument, which de-skilled the professional brewers, right? You didn't need to develop the sort of empirical skills and the experiential judgments as much anymore. And in fact, it asked brewers to learn a new set of skills. which included the sort of proper manipulation and understanding of what the thermometer was telling you, and also the mathematics, which I'll sort of get to a little bit in the talk, that were required to properly apply thermometric readings to the brewery. So at the end of the talk, I'll hopefully convince you, which I'll talk about those aspects of Combrune's program which were successful, and why they were successful, being that they augmented the traditional skills of the brewer rather than disrupted it. Okay. So Combrune was inspired by the work of Herman Boerhaave, who I just mentioned, but also Peter Shaw, who were two, again, elite or philosophical chemists who advocated on some level for the application of chemical knowledge or philosophical chemistry to improve the arts. Now, Boerhaave was, as I said, a professor of chemistry at the University of Leiden, who published a very influential textbook, Elementa Chemiae, pictured there on the in the middle of the slide. That's the first Latin edition. There were several English editions that were available to Britain and that Combrune clearly read. And then the other person was Peter Shaw, who Combrune communicated with directly. And it was Shaw, in fact, who in many ways encouraged Combrune to sort of promote his program for reform. So the result of this influence of both Shaw directly and Boerhaave through his writing were two books published by Shaw. The first one, an essay on brewing, which was published in 1758, and then an expanded follow-up, expanded by Shaw or encouraged by Shaw to expand, called The Theory and Practice of Brewing from 1762. Now, Combrune had originally published his essay on brewing as a manual for brewers. It was dedicated to the Worshipful Company of Brewers in London. But again, the success of this book initially sparked the interest of Peter Shaw, who encouraged Combrune to expand its content. Combrune did this most likely as an attempt to gain entry into philosophical circles, perhaps even gain election to the Royal Society of London. But this wasn't to be. The theory, even though he published his theory and practice of brewing in a nice quarto version, like a library book that you can sort of put, like a gentleman could put in their library, but this did not bring the desired result. In many ways because of some criticisms of the book, and I'll get to that a little bit later on in the slide, or later on in the talk. So the core argument in Combrune's essay was that, as I mentioned earlier, regular rules and principles needed to govern the practice of brewing. As Combrune argued in the introduction of the book, that, well, he claimed, of course, that the English brewed the best beer in Europe. But the problem was that there was a great difference, what he said, a great difference in point of excellency, chiefly owing to the want of principles to rule and direct them. So that even though the British brewers brewed the best beer, that the maintenance of that quality, of the same quality of beer every time, was the problem. Right. So in some sense, he said, but Combrune argued, was that the English brewed the best beer by accident. Right. And that the remedy was to figure out what principles needed to be applied to brewing in order to get the best beer every single time. Right. So to remedy this, Combrune argued that brewers needed to learn and pay attention to chemistry, at least some parts of it. And according to Combrune, at the time of the publication of his essay on brewing, he claimed to have been doing this, applying the principles of chemistry to his brewing for 17 years by this point. So we're talking starting in the early 1740s. So Combrune applied theories and principles that he found in Boerhaave's book. Specifically, he used the 1735 Timothy Dallow translation of Boerhaave's book, which is just Elements of Chemistry, and tried to apply them to the brewing process. Now, Combrune kind of announced the fact that he was advocating for the application of chemical theory or chemical philosophy to brewing right at the beginning of his book. If you see there the image on the right side, there are the chapters of the book there, and you can see that it doesn't begin like a usual brewer's manual where it would begin with something like how to choose the malt or an explanation of what, an overview of brewing. It's nothing like that. Instead, he borrowed the structure from Boerhaave's Elements of Chemistry and started by talking about, in very philosophical terms, the four chemical elements that Boerhaave had used to organize chemical theory in his book: fire, air, water, and earth, and then added another section after earth, specifically focusing on the thermometer. So the idea here is that you're getting a little primer of chemical theory and then a little primer on the thermometer, how you use it and how you understand it, before you even begin to talk about brewing. Now, Boerhaave's chemistry, again, is all over this section of Combrune's book. The first chapter there, as you can see there on fire, summarized a much longer discussion, kind of paraphrased from Boerhaave's Elements, in which the Dutch professor presented philosophical arguments about the need for using thermometers. And again, Combrune reiterates Boerhaave's argument that the human senses, sight, touch, occasionally smell, which the chemists traditionally used to regulate heat during operations, was simply inadequate because they could be fooled. A famous example that Combrune repeats that you can find in Boerhaave is the example of caves. If you go into a cave, the idea here is that the cave maintains the same temperature, or in the 18th century parlance, the same degree of heat all year round. But if you go into the cave on a hot summer's day, you will perceive that heat as being cool. However, if you go into the cave on a cold winter's day, you will perceive the heat in that cave as being warm. So the idea here is that human senses could be fooled, right? That you need a thermometer to tell you that no, the heat in the cave or the temperature in the cave is more or less the same all year round. And by analogy, Boerhaave and then Combrune says that human senses can be fooled, especially when trying to determine heat, in all sorts of contexts that are applicable to chemistry and, for Combrune's argument, for brewing. There are also some changes in heat that were either subtle enough to escape human perception, or some were too intense. For example, you can't tell that, for example, when you boil water and water's boiling, that the temperature doesn't go up anymore, right? You need a thermometer to be able to determine that, because you can't put your hand in or near boiling water and determine that it's not getting any hotter as it's boiling, right? So yeah, you all understand that. Yeah. So uh, so Combrune stated that again, following Boerhaave, that what the thermometer measured was the presence and action of this subtle fluid which was for Boerhaave what he thought the element fire was. So it was a subtle fluid that when it gathered in one place, the heat would increase, which was readable on the thermometer. And then as the fire dispersed, there was less fire, the thermometer would go down. And Combrune just basically adopted that philosophical understanding of how the thermometer worked. Okay. Um, so then in the rest of the book, Combrune then begins the project of applying the thermometer and some other aspects of Boerhaave's chemistry too, to brewing. Before we get to that, I just want to take a minute. This is a slide that I show to my students when I talk about the history of brewing. Just to make sure that everyone understands the terminology, because we're going to be talking a little bit about the brewing process, and some of the terms are going to that I'm going to be referring to in processes are from brewing, and you kind of have to know that. So um, uh, you can see on the left hand of the slide, we've got malting, mashing, boiling, fermenting, and conditioning. There's lots of other things that going into this. So this is just a bare bones kind of quick and dirty review. Malting is the process where you take barley and you allow it to germinate a little bit, then you dry it out and you put it in a kiln to kind of roast it a little bit to make malt that is then applicable for brewing. Mashing is where you take the malt, you add some water that extracts all of the, whoops, you add water that extracts all of the sugars and all the other goodness from the malt, and you create a liquid, a solution that the brewers call wort, spelled W-O-R-T. The wort then is then boiled for a time, an hour or two. Basically, it purifies it, and it's necessary well, in modern terms, denature some of the proteins and so forth. At which point, the boiled wort, is allowed to cool and put in a fermenting vat where it is fermented. And in the 18th century, it is often, well, today too, inoculated with yeast or some kind of agent that at the time was known to cause to increase or promote fermentation. Just a little side note here: in the 18th century, English brewers did refer to that stuff that you put in the wort to make it begin to ferment as yeast. Although their understanding of yeast was not ours, they had no idea that it was uh, that it was a living organism or anything like that. Right. So for them, it was just a chemical process, and you basically got the yeast from your previous brew when a wort ferments. As the yeast becomes deactivated, it precipitates down to the bottom of the fermentation vat, and brewers would save some of that, dry it out, and then that would be the stuff that would be used to induce the fermentation in the next batch of beer. That's about as complicated as a complex and understanding as it got at that point. Okay, so quick and dirty brewing. So for Combrune, uh, let's see, that's my thought here. Okay, so there's a couple of uses for thermometry that Combrune that shows, or various uses of Boerhaave's chemistry. So, for example, in fermentation, as I sort of said, fermentation is one of those topics in 18th century science period that was a little bit of a mystery. Lots of different understandings of like how this started, of how fermentation worked, because you have basically sugars that somehow through some kind of chemical processes turn into alcohol. And there were lots of different understandings about how and why that happened. Combrune used Boerhaave's understanding of fermentation because Boerhaave was his chemical authority. And so what Combrune basically said was that fermentation is a process. Well, so for Boerhaave, alcohol was the what Boerhaave called the food of fire. So it's kind of a version of an inflammable principle. And Boerhaave argued that all plant matter had some of this inflammable principle in it. And so what fermentation was literally a process where the sugars and the other vegetable matters in the fermentation were broken down to release that alcohol, that inflammable principle that was always there. So it's just a matter of breaking down and releasing. And so Combrune puts forth this theory of what is supposed to be happening in the fermentation. Now, he points out, however, that the degree of heat or the temperature of the fermentation is very important. Again, following Boerhaave's recommendation, Combrune says that when you get a temperature that is below 40 degrees Fahrenheit, the fermentation slows down because the motion of the particles and stuff are too lackadaisical, and you can't effectively extract the alcohol from all the vegetable matter in the wort. However, once you get above 80 degrees, right, the action is too intense, and there's a propensity the fermentation doesn't go very well there either, because the alcohol sort of like kind of boils away. So you have to keep it between 40 and 80 degrees Fahrenheit to get a good fermentation and a good production of alcohol. Combrune also argued that you could use thermometers to check the strength of your wort. So when you extract all of the saccharins and all the saccharides and all the other good stuff from your malt, um, the you need to know whether your extraction will give you a beer with a good alcohol content, or whether the wort is only good for a weaker alcohol. And this is important for things like excise, and also you can charge more money for stronger beer, right? What Combrune does is applies a little bit of philosophical knowledge, and he says that he knows from Boerhaave and other people that when you have anything dissolved in water, it will lower the boiling point of the water. So what he says is what brewers should do is take a little bit of the wort, boil it, measure the temperature at which the wort boils, and from there you can then estimate the strength of your wort. The lower, the more that the boiling point is depressed, the stronger your wort is, and the better beer, the stronger beer you'll be able to brew. Now, perhaps the most influential part of Combrune's theory had to deal with mashing. Now, recall that mashing is the process where a brewer extracts all the sugars and all the other good things from the malt. Now, this was a kind of a tricky process because in the 18th century, brewers knew from experience that that water that was too cold, too cool, and you put cooler water on the malt, that you wouldn't get a good extraction. The wort would be weak. On the other hand, if the water was too hot and you put too hot of a water on your mash, the mash would sort of clump up, a process called setting, and you wouldn't get a good extraction there either. So the idea here is that you wanted, as a brewer, to kind of hit the proper mashing heat. uh, to get the maximum extraction of the sugars and all the other stuff that you want to have in your beer, right? So, um, so the thing is, um, what you want to, so what Combrune, or so how this was traditionally done is that the water for mashing was boiled in a giant copper container called a copper, and there's a picture of one there on the slide. And you boiled that, right? But the boiling water is too hot, so you have to let it cool down. And so, according to traditional methods, a brewer would have to use all sorts of empirical methods to figure out when the water had cooled down enough in order for it to be used to get a good extraction from your mash. So the thing is, the manuals before Combrune basically talked about doing things like waiting till all the steam coming off the water had settled down to such an extent that the brewer could like look into the kettle, into the copper, and see their reflection clearly. So when it cooled down enough that you could see your reflection clearly, then the water had cooled enough to be used for a good extraction. Other methods suggesting sticking your finger in or sticking the back of your hand in. And if it was hot enough, most of the manuals would say till you could barely stand it, right? You could just tolerate the pain. Then it was at a good level, and you could, it was good for mashing. Um, Now, to help things along, what a lot of large scale brewers would do would be to boil the water and then basically through trial and error and experience had figured out that if you poured some cool water in the copper a certain amount, that it would cool the water in the copper more quickly. And ideally, if you'd like, through trial and error, you could get it so that you would get it at a good final temperature to get a good extraction, right? But this is the kind of thing that Combrune thought was ridiculous, and that you should use thermometers to help you uh, to help you get the proper mash temperature every time. So what Combrune did is this, and this is from his book. Uh, Offered using thermometers and a little bit of mathematical calculation to be able to get the proper heat each time, right? So what he did is, as you can see there on the slide, right? You know that the temperature of boiling water is 212 degrees, right? And in this particular calculation, he says there's 22 barrels in the copper that have been boiled. And you multiply those together and you get a number, which is kind of a rough calculation for the amount of heat in the copper. And then what you do is, if you have cold water, you put your thermometer in the cold water, get a thermometer reading, and uh, you can figure out how much cold water you have, and then pour in the cold water into the boiling water. Uh, and by basically adding up the total amounts of heat and dividing it up between the water that was in the copper plus the cold water you added, you could then basically come to the degree of heat that the resultant mixture of hot and cold water should be. Now, the idea here is that you do this, and for the particular beer that you're brewing, you figure out what the ideal mash heat is. So if it's 161 degrees, like the example on the slide there, right? You can sort of back calculate between how much water's in your copper and then how much cold water at a certain temperature you need to like pour in to get it to 161 degrees, right? And Combrune says that you should do this for every, every sized copper. You can adjust the amount of water you pour in depending on how cool the ambient water is, and so forth, right? But the point is that Combrune suggests to regularize the extraction of all the sugars and the goodness from the mash, using thermometers and a little bit of mathematical calculation, and you should get the proper mash heat you need every time. Okay. Yeah. I have to point out that in the first version in his essay on brewing, Combrune himself didn't actually suggest any ideal mash heats for any brews, but he actually rectified that and included a few in his expanded edition, The Theory and Practice of Brewing in 1762. Now, on first glance, it would seem, if you were to look at the reviews of Combrune's book, first his essay, but really his 1862 sort of expanded version, it wouldn't seem as if Combrune's application of philosophical chemistry to brewing was a success. Brewers and advocates of improving the arts and trades criticized his system for being too philosophical, for trying to undermine the traditional practices of brewers rather than improve them. But then on the other hand, from the perspective of natural philosophers and philosophical chemists that he was trying to impress, because he wanted to build some philosophical bona fides so that he could get elected to the Royal Society, which was kind of like the his social aim in doing some of this. They argued that his methods were either out of date or misapplied, or certainly not novel enough to be considered philosophical. So just to explain that a little bit, by the 1760s, when his work was being reviewed and talked about, Combrune's use of Boerhaave's chemical theory was somewhat untenable at that point. Boerhaave's theoretical understanding of the thermometer as an indicator of the presence of fire in a solution, for brewing anyway, had been called into question. Work of experimentalists such as Joseph Black, there on the slide, were beginning to undermine the theory and beginning to question what the thermometer actually measured. And again, the simplest example of this is the boiling water, right? You put boiling water, you put water in a vessel, you stick a thermometer in, you put it on some heat, right? The temperature goes up until the water starts to boil, at which point the temperature does not increase. So the question is, if the thermometer is measuring fire and you're adding fire, continually adding fire to the water, which is causing it to boil off, where is that extra fire going? And therefore, what is the thermometer actually measuring? It's not really the presence of fire. So it opens a whole range of questions. And there were also questions about the calibration of thermometers too. It turns out the expansion of mercury, on which any mercury thermometer is grounded, is not linear with respect to heat. So there were some problems there. So there was a lot of philosophical problems with the instrument, you might say. On the other hand, for practical brewers, they again rejected it as being too philosophical. And I'll give you one example. In 1760, excuse me, a brewing manual called The Complete Brewer came out, which was attributed on its title page to, quote, a brewer of extensive practice, who was later revealed to be a retired brewer named George Watkins. Didn't mention the thermometer at all. The aim of the book, in a seeming contradiction to Combrune's program, according to the preface, was to bring sound practices and principles to professional brewers. That is, in his own words, to lay before the private family and the industrial brewer the secrets which brewers carefully keep to themselves. However, these principles of brewing were based on the old methods that relied on the experiential training of the brewer, knowing the proper things like knowing the proper season to brew, choosing the malt, the hops, keeping one's utensils clean, reading empirical signs like seeing your face in the copper to know that the water had cooled down enough to be at the proper mash temperatures and so forth. So it's kind of almost like a doubling down of the old method against Combrune's program. Uh, in fact, John Richardson, who himself is a famous innovator and brewer, and Richardson is famous for inventing the saccharometer. I've given a picture of one of those on the slide there. A saccharometer just basically test the strength of the wort, but instead of using the boiling point like Combrune does, test the specific gravity of the wort. And this is the way, if you've a home brewer or even worked in a brewery, that's the way you test the strength of the wort nowadays. So Richardson's method carried on, but Richardson's critique was again that Combrune was too philosophical, and that his final comment was that Combrune needed to value experience over experiment, was the way that he described it. However, despite all this, some brewers, and especially commercial brewers, um, kind of rapidly in the 1760s began to adopt certain aspects of Combrune's practice, especially the stuff relating to thermometry and the thermometry of and doing the calculations around the temperature of the mash water, of mashing heats. Evidence suggests by the mid 1760s, brewing thermometers were in fact being used in some larger scale London breweries. By 1765 and 1766, London instrument makers such as George Adams and Benjamin Martin were advertising in their catalogs thermometers that were specifically designed for use in brewing. And how do we know this? If you see the picture in the upper right corner there of the finely dressed gentleman experimenting with his thermometer, you see that there's a scale on the thermometer and then it has a rather long like bottom. So brewing thermometers, because they're used in large vats, tended to have longer sort of, the bulb tended to be on the end of a much longer tube. And you can just sort of fill in and adjust the scale as you needed. So again, thermometers specifically designed to be used in a large scale setting. In 1768, another brewing manual called Every Man His Own Brewer, again published by, quote, a gentleman lately retired from the brewery business, advocated for some of Combrune's methods, especially determining the math heats with thermometers. He lamented that, quote, without the thermometers, you can only judge a proper degree of heat in the old way, that is, seeing one's face in the water. And then later in the text, he presented specific thermometer readings to be used by brewers in various contexts, such as that 40 degrees was the best ambient temperature in your brewery for brewing, that 135 degrees was the best mashing heat to extract materials from malt, and that 55 degrees was the optimum fermentation heat. All right. By the 1790s, brewing guides for so-called home or country brewers, as well as industrial brewers, were universally either recommending thermometers or lamenting the fact that industrial brewers could use thermometers, but that home brewers sometimes couldn't because thermometers were expensive. And in fact, there was considerable debate by the late 18th century about the proper heats for fermentation and mashing and other processes in the brewing process. Um, uh, this was exacerbated by the fact that, again, by the 1790s, proper mash heat for extracting, all the sugary goodness from malt was considered to be by many in professional brewers proprietary knowledge. By the turn of the 19th century, instrument makers sold brewing thermometers with removable scales to suit the brewer's need for secrecy in their recipes. A master brewer could simply mark on the thermometer tube what the proper heat of a particular operation needed to be, and then could remove the scale, thereby hiding the proper the proper heat, whatever it was, um, from visitors or even his own workers who might reveal this knowledge to a competitor or start their own brewery or something like that. So these examples suggest that by the late 18th century, brewers integrated Combrune's brewing thermometer into their beer making so long as it helped them streamline production without disrupting their established practices. As such, they adopted the use of the Fahrenheit thermometer to control mash heats, but were much less concerned with problems such as the decline of Boerhaave's theory of fire or some of the issues of thermometer calibration, which concern the philosophical chemists or the natural philosophers and so forth. Um, uh, for my last example, and this is great, I want to focus on how much Combrune's method of calculating mashing heats became integrated into brewers, especially the large-scale brewers. On the chart, I have a table from a book published by Henry Goodwin. By the 1790s, Goodwin was the fourth or the fifth or the sixth, depending on which source you consult, largest brewer in Britain. And he was known as an innovator. For example, in 1784, Goodwin had installed the first Bolt and Watt steam engine to power his London brewery. In 1796, he published a book, The Brewer's Assistant, comprised of tables to be used to speed up calculations that one commonly needed in the brewing business, such as tables for the conversion of units that one used in a brewery, hogshead to barrels to gallons, hogshead, that great unit of volume that we still use today. So conversions of units, calculating excise taxes, and so forth. This table here, table number 23, is interesting because it embodies a version of Combrune's method of calculating for boiling heats, or for mashing heats. And what it does is it has on the left a table for the degree of heat that you want your mash water to be. And along the top is a table for the heat of the cool water that you're going to pour into your boiled water. And how the table works is, let's say that you wanted whatever heat of, say, 160 degrees to be your mash water. You basically take the temperature of your cool water, and what it does is that decimal is what you have to is what you multiply. Well, I'm sorry, getting ahead of myself. Whatever your volume of cool water is, you take the temperature, and then that decimal refers to you multiply that times the volume of your cool water, and it tells you the volume of boiling water that you need to add to the cool water to get the mash heat that you want. And again, what's interesting about this is that what Goodwin has done had sort of flipped the script that you only boil the amount of boiled water that you need to get the mash heat that is the right one for your particular process. Because, of course, as an industrial brewer, you go through a lot of fuel. Fuel's expensive. So you only want to use as much fuel as you need to heat up the water to the mash heat that you need. You don't want to waste money by boiling a whole kettle, a whole copper full of water and allowing it to cool, or even to add cool water to it, right? You start with the cool water and only add as much hot water as you need. And using Combrune's calculations in this table, you can figure out fairly reliably exactly the amount of boiled water you need to add to the cold water. Okay. So with that, that's the end of my stuff. Just as a conclusion, uh, just to ask the question, why were thermometers adopted? And my answer is they promoted the efficiency of brewing, especially for large-scale brewers. Thermometers became a tool to help industrial brewers uh, efficiently regulate their processes to get a product that is at least reasonably the same quality each time, uh, and and that they didn't really care about all the philosophical stuff that Combrune wanted to bring in, just as long as his calculations and his protocols with the thermometer worked, that was good enough for them. All right. Thank you
Thank
very
you very much, John, for a wonderful talk. And I think that final point of yours would apply across the whole range of applied chemistry. But the
much. Oh,
people who
yeah.
actually do this stuff are only interested in what actually helped them to do this stuff. And the theory is all very well, but it doesn't really have much to do with what they really do. I mean, that applies to things like dyeing, sugar, and it's better than he like to mention in that period, and indeed for a long time afterwards. John, I have one very good question that somebody posed, but before I pass on to that, I would like to not so much ask you some questions, I would much to try and tease out some of the points you've made. So in a sense,
Okay.
I'm sort of trying to sort of clarify some of the points you made, if I may put it that way. The first is, how much impact did Combrune actually have on the brewing industry? I mean, you've talked about the use by larger brewers of thermometers, but at the end of the day, would it be true to say that his impact was more rhetorical than actual?
Um, I think that I think that he uh um I don't know. My thought is that he did have an impact in terms of introducing thermometry into practice. Although I have to say that uh I don't know that for sure. I don't know if there may have been other brewers who were experimenting with thermometers before Combrune. And when Combrune published his two books, 1758 and 1762, kind of put it out there in the world, it certainly became the focal point for discussion. Um, with during the 1760s. And like I said, as you see by the late 1760s in the brewing manuals that are published, um, they're all talking about thermometers. Whether I don't know whether or not they're using them, it's unclear by that point. But brewing thermometers are available, um, and so it does seem like if he's not the only brewer that is using thermometers at this time, his publications do seem to be the focal point of the discussion and of the debate about them. So,
Okay. Now, to what extent did the introduction of the thermometer, okay, let's forget about Combrune, let's just focus, as you did, on the introduction of the thermometer. To what extent did that lead to the consolidation of the brewing industry? Because in the early 18th century, the brewing industry was very much a cottage industry. There were
Yeah.
loads and practically everybody made their own beer. I'm exaggerating, but I mean, Oxford colleges made their own beer. There were lots of brewers.
Yeah.
To what extent did these scientific methods in general and thermometry in particular gradually lead to the consolidation into larger, more efficient brewers?
I don't think the thermometer itself like drove that process. I think there were you know um, the increase in size of breweries, especially well in Britain, in big cities like London, uh, was happening, really kind of at the same time that Combrune was starting his experiments with thermometers. I think that the thermometer was adopted um, by the large scale brewers who were getting bigger and bigger for
Mm,
other forces dealing with like markets and competition and the influx of people into cities like London, right? And that the thermometer was seen as a tool to to speed up and make production more efficient.
okay,
Um, but I don't think the thermometer itself drove the growth of the brewing industry itself. That at
okay,
least that's my take on it.
okay.
Yeah.
Well, you could have made a claim, but you shouldn't.
Yeah. The thermometer did it all. No.
Mm. Now, you touched upon this, but I would like to bring it out a bit more. Which was the more important instrument for brewing? Was it the thermometer or the hydrometer?
Well, so I don't at the time. I'm not. I'm not sure because again, by the 1790s, if you were, a brewer who was up on the latest things, you would of course use both,
Mm.
right? Um,
And indeed,
uh,
for the hydrometer, you need to know the temperature.
yeah, you do. I mean, you could sort of ballpark it a little bit, but yeah, but you would need both. And I mean, of course, if I want to be Combrune's advocate, I could say that you could measure like the strength of the wort and stuff like that using just the thermometer and the boiling point, but that would require a whole bunch of
Yeah.
well, I guess the hydrometer sort of does too. They're measuring versions of the same thing. So yeah. I guess maybe I'll make this claim. How about this? You can get by with just a thermometer,
Yeah.
right? But you can't get by with just a hydrometer. How
Yeah.
about that?
Okay.
Yeah.
Okay. Good point. Finally, and I'm making a rather obvious point here, but Combrune and his fellow scientists of, of course, we can't really call them scientists, philosophers, his fellow philosophers of the 18th century, didn't really dig very deep into the actual mechanism of fermentation, did they? I mean, they didn't make any progress in looking for an active principle, which of course we now know is diabase.
Yeah, yeah, yeah.
They didn't really go into that stuff, did they?
Well, I mean, so I think, they're like Boerhaave did experimentations with fermentation to see what kinds of matter would ferment, what the products would be. Um, you know, but at some level, uh, you know, there wasn't there wasn't, until you get microscopes and Pasteur, right? There
Yeah.
isn't really a wedge into kind of understanding what's really going on. So there was a lot of speculative theory, right? So like I said, for Boerhaave, fermentation is about releasing the alcohol or the spirit of wine or the food of fire that was already there. Um, for Stahl, it has to do with like phlogiston and right. And of course, there were other theories of fermentation too that hypothesized different different kinds of entities and processes, but it was all very speculative. Um, just because uh, you could do all the fermentation experiments you want, but until there was a wedge to really kind of like see what the agent of fermentation was, and to be able to kind of understand it in a more careful way. You were just going to get speculative theories, and so yeah. But I have to say that brewers empirically did know that you had to take the leftovers, the dregs, the precipitated yeast from the previous brew and inoculate the next brew in order to get it going quickly. Now, you can have your wort just sitting out and let it kind of get uh you know sit there for a while, and it would begin to ferment, kind of like when you start a sourdough as a baker. But the thing is, you didn't know what you were going to get then, right? If you wanted to, I think brewers would probably, once they had a brew that they liked, they kind of preserved that yeast and kind of used it in their succession of the things they wanted to brew. Because if you've ever done any home brewing, you know that you have to keep things clean, and you have to put the yeast that you want in there to do its thing. Because when you get other things in there, you can get bad, and no, they're not too bad, but like you get things that are off flavored, sour or vinegary, or things that you can't sell as beer, right? So.
Quite so. I have a very interesting question here from Rob Lee that I would like to put to you. I'll read out the whole text. In the second half of the 18th century, Malta noticed a large increase in the amount of beer obtained from a quarter of malt in the London porter breweries. Porter, of course, is a type of beer. How much of the increase do you think was due to the application of Combrune's idea on a thermometer use, and how much of it was down to other factors, such as an increase in the barley price, leading to a dilution of the beer strength?
Hmm. That's an excellent question. I have no idea,
Okay,
but I mean, probably a little bit of both, maybe. But that's an excellent question. I do know this, that um, professional brewers would try to get every bit of value out of their malt, right? So the thing is, when you got as a brewer, when you got a new batch of malt, you would do an extraction, right? And then you would sort of pump off that wort, and then you would brew like your strong beer or your best beer with that stuff. And then you would add in more mash water. And oftentimes, there's in the manuals, there's descriptions about, you use like a higher temperature, or, it's a different, a stronger, like hotter extraction water, and you do some other things to it, and you do another extraction. Now that wort isn't as strong or as good as the first wort, but you can brew with that too and make what they would refer to as small beers or weak beers. So like a thinner, lighter, lower alcohol beer from the second extraction. But yeah, but they would. It was definitely, you know, part of any when you have a professional brewer who's wanting to maximize their profits and things, figure out ways to get every little bit of value out of your out of the supplies and the that you have to purchase. So.
okay, we have a question here from Jeff Seaman, who says that, and they're both, by the way, I should not say, but both are interrogers. Both the people asking the question have said it was a very good lecture. So, but he asked, have you asked any modern brewers if they still rely on intuition and sensory perception rather than any scientific measurements in their processes?
So, yes. Um, so I live in Richmond. There's a brewery here called Hardywood. It's a local brewery. I mean, they're, I guess, what you would call they're regionally popular. Um, but when they opened up, like all of these new craft breweries do, they allow you to come in and walk around the brewery and talk to the different people and um, they pretty much do everything with instruments, So when they like boil, they do boils and things. It's in these big stainless steel vats. You can't really look in there. You can't, and they, take out samples and they have a little laboratory set up on the side where, they analyze every few, I don't know how often they do it, but while it's fermenting and all the stuff, it's all done um scientifically now. Although I do have to say one thing that they did tell me, which I as a home brewer, I kind of understand, but it also made me think about like industrial produced brews, like which is that uh, even when you have that level of scientific control, not every batch of beer turns out exactly the same. Because when you're dealing with a living organism, right, it adjusts, it changes, things go funky, right? And so I asked them, well, then how do you make sure that like every, can of Budweiser is the same? And what they said was, well, what you do is like the really big commercial breweries like Budweiser or, sure there's giant commercial brewers like InBev or in Europe too. What you do is you brew like 20 different vats of the stuff and they're all a little bit different. But what you do is you have a model like a target recipe, based on its scientific measured characteristics. And the beer that you get in your can that is more or less the same exact beer every time is a combination of like a little bit from that vat and a little bit from that vat to like build the characteristics of the marketable beer that you want to be the same every time. And that's how they do it. Because I asked him as a home brewer, like sometimes you do something exactly the same and it just goes off the rails and you get something that is not at all what you expected. And I just thought it was because I'm a home brewer and don't know what I'm doing. And they're like, no, no, no. Even the professional brewers have this problem, but what we do is we brew several batches at the same time and mix them together to get the product that we want. So,
John, I don't know why, but I've had two questions about gossip brewers here. One is from Rob Lee, who asked the original question. Have you seen any evidence that gossip brewers took up Combrune's ideas? And if so, what was the extent and when? But I'm not
what,
sure.
what, what, who took up
Right.
Combrune?
Do you have any evidence that gossip brewers took up Combrune's ideas? And if so, to what extent and when?
What kind of brewers? I'm sorry, I'm not
Scottish from Scotland.
oh, cottage. So the thing is, there are manuals in the late 18th century about the cottage brewers, and the issue there seems to be that thermometers are expensive, right? So if you are, a whatever, a cottage brewer, you're brewing for
Ron,
your estate.
can I stop you there because I think there's been a misunderstanding. I meant Scottish, Scotland, not
Oh,
cottage.
Scottish. Oh, sorry, I thought you said cottage. I'm sorry, Scottish. Um, I'm not sure. My answer is probably, uh, but I don't know for sure. I don't know for sure.
Okay, let's move on. Somebody else said, but Innocent Gunn, who is a sort of niche Scottish bird to produce very strong beer, is looking for five beer tasters to work with them for a year.
Is that a job offer?
It's a job offer, yeah. So I don't know. Maybe you might like to take a sabbatical. Maybe you might like to take a sabbatical
Yeah,
and
but
go and
like,
work with them for a
I'm
year.
not going to say that's my dream job, but it's kind of my dream job.
Well, I think on that note, John, we should call it a day. We've gone
Yeah.
on for about an hour now. People are beginning to drift away. So thank you
Yeah.
very much again, John, for such a lovely talk.
All right.
We always enjoy having you, and I'm sure you get lots and lots of views on YouTube as well.
Yeah,
Next
yeah.
week, next month, we're having Dominique Cardon, who is a French historian of dyes, and she'll be talking to us about the history of dyes, but I'm not sure of the exact talk. But I know she's incredibly informative and knowledgeable about the history of dyes, so please come along next month, same time, same place. Third Tuesday of the month, which I think is next month is the 16th. It can't be the 16th. No, next month it's going to be the 21st, in fact. So come to us, 21st of October, 2 p.m. to hear Dominique Cardon. Then we've got more talk coming along after that as well. But in the meantime, please go away and have a good afternoon, or in your case, John, a good morning. And
Yeah.
thank you once again, everybody, for coming along and listening to one of our talks. So thanks,
Yeah.
John, and thanks, everybody, and goodbye.
Thanks, Catherine.